Hi there, Geometry. It's Mr. Lamb again, coming to you with number 5 in the sections from the final exam review. And this one is going to be another quick one. It's only 4 questions on quadrilaterals. So a couple of things that we need to know about quadrilaterals. And really, in this case, this is basically some polynomials as well. So questions 1 and 2 are going to talk about polynomials. So as I take a look at questions 1 and 2, I should remember that if I want to find the sum of the interior angles, so sum, I don't want purple, let's change this. Let's go, there we go, that's something new. Sum of interior angles. I remember that we just talked about this. It is 180 times n minus 2. So the number of sides minus 2 times 180. So as I take a look at question number 1, I can see that it has 1, 2, 3, 4, 5, 6 sides. So the sum of the angles, remember that little fancy sigma, we called it. The sum of the interior angles, in this case, would be 180 times 6 minus 2. Well, 6 minus 2 is 4, and 180 times 4 is 720 degrees. So these have to add up to 720 degrees. So the easiest thing to do is to take 720 and start subtracting out 120, subtract out 95, subtract out 120, subtract out 125, subtract 72, and you will get x to be 88 degrees. A little known fact, 88 is also the number of miles per hour the DeLorean needs to be going in order to travel back in time, in case that comes up on your final exam. Question number 2. This figure is 1, 2, 3, 4, 5 sides. So I can do 180 times 5 minus 2. Well, 5 minus 2 is 3. And 3 times 180, this sum here needs to be 540 degrees. So 540 degrees. So if I do 540 and I start subtracting, subtract 95, subtract 125, subtract 105, subtract 116, you will get x to equal 99 degrees. Now to find y, if I know this is 99, and x and y make up a straight line, then 99 plus y has to equal 180 degrees because of that straight line concept. So that means y is 81 degrees. So making sure that we understand and we know that the sum of the interior angles is 180 times the number of sides minus 2. As I scroll down and take a look at questions 3 and 4, it says find the value of the variable for which A, B, C, D is a parallelogram. So if it is a parallelogram, one of the rules I know about all parallelograms are opposite sides are congruent. So the top and the bottom have to be the same length. Well, if that's the case, then 2x has to equal x plus 8. And then I'll solve. Subtract x on both sides. X is equal to 8. And I could have done it by setting the other two. I could have said x equals 3x minus 16. I could have subtracted 3x on both sides. I would have had negative 2x equals negative 16. Divide by negative 2, I still would have gotten 8. It does not matter which side you choose. The other thing about parallelograms that you should know is the diagonals of parallelograms bisect each other. So that means this long piece and this long piece will be the same length. The short piece will be the same length as the short piece. So it does not matter which pair I choose. I'll choose the short piece. So x has to equal 6x minus 15. Subtract 6x on both sides. 1 minus 6 is negative 5x equals negative 15. Divide by negative 5, and x is equal to 3. Again, if you would have used the other ones, 4x minus 6 is equal to 2x. Subtract 4x on both sides, you would get negative 6 equals negative 2x. Divide by negative 2, and you would get x to be 3. Well, I told you it would be quick, and that is the end of the quadrilaterals.